Okay, let me start today's session. So we will continue with the design of band limited signals for controlled ISI. So in the previous classes, we have learned what do we mean by the ISI, the concept of zero ISI, and the concept of controlled ISI. So since there was a gap of nearly 1 week, let us recap what we have learned. So the aim of today's topic is design of band limited signals for controlled ISI. That is the topic, and we have started the topic. So to have a proper continuation, let us recap what we have learned in the previous class. Okay, so therefore let us go to the previous slides itself, a single slide which can explain you the every concept of ISI. So this is the basic block diagram of a communication system wherein we are sending symbols over a band limited channel. Okay, so over a band limited channel. So now at the receiver, if you try to observe the transmitted symbols, or if at the receiver if you observe the symbols, then this is the basic equation, that is y of mt equal to x of 0 into am plus sigma x of mt minus nt into an plus w of mt. What is this? This is the received symbols. We have transmitting a set of symbols every t seconds. We are transmitting every one symbol every t seconds. So at the receiver also, every t second we are going to observe the output, or we are going to observe the sample. So over there, now if you observe, this is the equation over this am is the desired symbol, but along with the desired symbol we are having the undesired one. How will you say that this is the undesired one? See here, y of mt, this is what I am sampling the output. At that particular sample, along with the desired one, we are getting the undesired samples. Undesired samples also are undesired values. Okay, so this undesired value or this term, it will be called as the ISI. So therefore, to remove the ISI, what we are supposed to do, we are supposed to make the second term or the summation term to be 0. So if you want to make the summation term 0, what is the best thing? X of mt minus nt should be 0. So this states this is stated by the Nyquist criteria. So by this equation number 13, you are supposed to understand the concept of ISI. So you have transmitted, you are transmitting symbols every t seconds. So at the receiver, you are observing the output. So at the receiver, what are you observing? Along with the desired symbol, you are having the effect of the other symbols also. So this effect, that is the second term. So this effect is undesired one. So this is called as ISI. So to overcome the ISI, what you are supposed to do, x of mt minus nt, you are making it as 0, or in other words, you are making the samples of x of t as 0. Whether you are making all samples of x of t as 0, no, you keep x of 0 as 1 and all other samples are 0. So that has been written over here. So the 0th sample is kept as 1 and all other samples are made 0. So this is the condition for 0 ISI. Your x of t should be such that it should satisfy the equation number 14. This was told as the Nyquist criteria. So if we do this, what are the effects? The effects are as follows. We are going to overcome the ISI. Yes, observe, we are going to, because these values would be 0 if you take this condition as per the equation number 14. So the summation term would be 0. Only what about this term x of 0? If you observe x of 0, it is 1. So therefore, only the desired term will be left out and all other terms will be made as 0. So therefore, if we satisfy equation number 14, we will get 0 ISI. Yes, so that we have understood. So the next thing is what happened? What happened? For that, we have chosen two choices for x of t. if we want to satisfy the equation number 14, then how our x of t should look like? So one choice was the sync pulse that has been shown over here. This should be the x of t. See here, at 0th sample you are having 1, and at all other samples you are having 0, which is satisfying equation number 14. This was having some practical difficulties. Okay, so therefore, to avoid that practical difficulties, we have chosen another solution for x of t, another option for x of t, that is called as raised cosine pulse. Okay, so when we use the raised cosine pulse, so what has happened? What was happened was there was an increase in the bandwidth. Remember, there was, what was the effect when we use the raised cosine pulse? There was an increase in the bandwidth. Along with the increase in the bandwidth, there was a reduction in the symbol rate. So if you want to use the raised cosine pulse for achieving 0 ISI, two things you have to undergo. One is the increase in the bandwidth, and other one is the reduction in the symbol rate or the signaling rate. So to overcome these two difficulties, so what the solution was given was the controlled ISI. So the controlled ISI is a solution for the following problem, that is the reduction in the bandwidth, the reduction in the the symbol rate. So whenever you are satisfying for whenever you are using or working for 0 ISI, what was you are observing? There was a reduction in the symbol rate. So what is the solution to have an appropriate symbol rate or exact symbol rate? So that would be discussed now. So what symbol rate we can achieve? The symbol rate we can achieve is equal to 2W. What is the symbol rate one can achieve? What is the maximum possible symbol rate one can achieve is 2 into W. So what is W? W is nothing but the bandwidth of the channel. So these things you are supposed to understand. Okay, so now to have an increase in the symbol rate, so what the solution they have given is controlled ISI. So what do you mean by controlled ISI? Controlled ISI is nothing but adding an ISI component or adding a non-ISI component. That is the meaning of controlled ISI that has been written. We allow one additional non-zero values in the samples x of nt. So what does this sentence mean? This sentence is nothing but the meaning of controlled ISI. Controlled ISI in the sense, what exactly it means? We are going to add one ISI component, or we are going to add the ISI we are going to add the ISI component. That is the meaning. So now how to analyze that is, see over here, you observe the equation number 20 and compare that with the Nyquist criteria. So you have learnt what was the Nyquist criteria. Nyquist criteria was told for 0 ISI. So to have 0 ISI, just let me go through the Nyquist criteria very quickly. So this was the Nyquist criteria for achieving 0 ISI. How the samples of x of t should be: at n is equal to 0, you are having 1, and at all other values, you are having 0 quantities. So this will achieve 0 ISI as per the equation number 13. So now, if you want to have controlled ISI, means you should have an ISI component, or I mean that I'm going to add an ISI component. So, okay, let us assume for the time being, we are going to add one ISI component. So therefore, in this summation, how many terms you are supposed to have in this summation? You are having one term, because we are interested in adding one ISI component. Okay, so let me add one ISI component. So therefore, over here, how this equation 14 would be modified? Remember what I'm saying is, so this is the equation to have 0 ISI. To have 0 ISI, this summation was made 0 as per the Nyquist criteria. Now what am I telling is, I am trying to introduce an ISI. So this summation, it should not be 0. So in other words, I will have only one term in the summation. I will have one ISI term. So this contributes the ISI, right? Wherein you are having so many ISI terms. So what I'm doing is I will have only one ISI term. So therefore, along with this x of 0, you can expect one non-zero component in x of t. Over here, just observe, along with x of 0, you can expect one more non-zero component. Okay, so therefore what happens in this summation, you will have one term. Okay, so that is what is going to happen. So there I will give a practical illustration also, just for the time being you hear this particular concept. Over here you observe, at n is equal to 0 you are having 1, and at n is equal to 1 also you are having 1. At all other samples you are having 0. Okay, so this is the case. Then if you go for the pulse diagram or the pulse shape, this is the shape of the pulse. Over here observe, at 0 you are having 1, and at the first sample also, see over here, and n is equal to 0 means this is the meaning. N is equal to 1, what does this mean? This is this time instant. So at both time instants you are having value as 1, and at all other instants the values are 0. Instants means you are supposed to understand it as sampling instant. Okay, at all other sampling instance you are supposed to understand. Okay, so this is the particular case. So what we have achieved is, just a minute. Okay, yes. What we are achieving is this. With this, we have introduced one particular ISI component. We have introduced an ISI component which is shown over here. By mere observing this equation, you may not get to know how an ISI component has been introduced. So what you are supposed to do, you are supposed to think back, or you are supposed to go back to the equation number 13 and find out. Okay, so what was equation number 13 specifying for 0 ISI? For 0 ISI, only x of 0 should be 1 and all other samples of x should be 0. Okay, but now if I want to introduce an ISI, so over here you should have a non-zero term. Then what will you happen? What will happen? Then you will get an ISI. So therefore, for that, achieving that particular case, to have an ISI, so at sample 1, at the sample 1, n is equal to 1, you are having another non-zero values. So that has been chosen. So with this choice, what we are going to have achieved is, we have introduced ISI component, but the symbol rate, the rate at which we are going to transmit the symbols, that would be increased. So to what extent it increased? It got increased to, the symbol rate would be increased to 2W. So that was the required thing. Okay. So now this pulse or this type of waveform is called as duobinary signal pulse. Why this has been called as duobinary means, here we have achieved a symbol rate of 2 into W. That is why this pulse, on using this pulse only, we have achieved a symbol rate of 2W. Therefore this pulse is called as the duobinary signal pulse. Okay, so remember, we have one ISI component. So let me take an example for this. So as we have told, as per this is the equation for x of nt, correct? X of nt, this is the equation number 20, you carefully observe. Okay, so now what have I done is, I am writing the equation for ym. So what is this ym? I am at the receiver. So at the receiver, what am I observing is, at the mth instant I am observing the output of the receiver. I have received one symbol, that is AM, correct? and into x naught plus what am I having? The other component am minus 1 into x1. Observe this. So this is the ISI component. How many ISI component I am observing? I am observing only one ISI component. Why are you observing only one ISI component? Because you have made one you have made, except at n is equal to 0, another component has been made non-zero, except at n is equal to 0 or along with n is equal to 0, one extra component would be made as non-zero quantities. So therefore you are having this terms will appear. You can observe x naught. X naught means what does that mean? It is nothing but x naught means x of 0. X of 0 is 1. Correct. X of 0 is 1. So what is this x1? This is nothing but x of t. X of t. What is the value of x of t? It is 1. So therefore that has been written. X naught means what you are supposed to do? X of 0. X of 1 andre ಏನು? What does x1 means? It is nothing but x of 1 into t or x of t. Okay. So this is how you are getting the output at the receiver. Along with the desired quantity, what are you having? You are having an extra term which has been shown in the red color. So this equation number 23 has been written considering the equation number 20 and the equation number 13. 13, you know what is the equation number 13. Okay, I hope you observe. I am using because this is the actual equation. Okay, and I am using this equation 20 also. Using all those things, I am writing this particular equation. So therefore we are getting one ISI component, or we are getting one unwanted component which you can treat it as ISI. Yes. So now for the time being we will ignore this noise component. So let us ignore the noise component. So what are you having? Ym is equal to am plus am minus 1. So for our convenience, for the sake of convenience, what we will do? We will make the summation of these two terms as, we will call it as bm. Okay. So now what is bm? This is convenience sake I am writing. So what essentially is bm means? Bm is the received signal at the mth signaling interval. Okay. So if you are observing the output at the mth instant, what are you supposed to get? You are this, that is called as bm. What are you supposed to get at the mth symbol? If you observe at the mth instant, if you observe the output, what are you getting? You observe along with the desired symbol, you are getting the previous symbol or the symbol at the previous instant. In other words, the bm, it contains the am along with the effect of the previous symbol. Okay. Or in other words, we can say the bm has the effect of the previous symbol also. So therefore, so how can we overcome that? That we will come to know. Before that, we will have a simple example of what we have learned. Okay. So now what is this? Don't forget this basic equations. So what is this equation? This is the uh, output sample. This is the output sample. So at the mth instant, if you observe along with the desired one, you are getting the other symbol effect also. Now as per the equation, so I told we were using equation 20 and 13. So as per equation 20, the x of 0 or x0 and x1, they are having the values of 1. So and if we forget this wm, so the equation 23 will get reduced to equation number 24. So this am and am plus 1, we will, for our convenience, we will call it as bm. So what is bm? Bm is the received sample or signal at the mth instant or mth signaling interval. So now if you observe carefully on bm, you are not getting the desired symbol, you are also having the effect of the previous symbol, which has been shown by the effect. How is the effect? The addition is the effect, what has been added? The previous symbol. Along with the desired symbol, previous symbol is also being added. So we will take an example for the equation. So this is the data sequence. The first row you are observing is the data sequence. So now we will have a simple convention. When you want to this is the data, binary data, but this binary data is pulse amplitude modulated. So means 1 has been identified as a pulse of amplitude 1, 0 has been identified as a pulse of amplitude -1. Don't bother about the very first column over here. Don't bother about this column. The data starts from this point. So 1 should be treated as 1 volts, 0 should be treated as -1 volt. This is a sort of pulse amplitude modulation. So this is the data which you are transmitting. Okay, yes, that is true. Then what you did, you received the signals. So the received signal is given by ym, or you can also treat it as bm. So what are you receiving? Whatever the transmitted symbol, along with the transmitted symbol, you are having the effect of the previous symbol. So what is the effect? The current symbol plus previous symbol is the one which you are receiving. You are not receiving the only the current symbol, you are also having the effect of the previous symbol as shown over here, plus the addition current symbol plus the previous symbol. Now we will take. So what am I receiving? So I am transmitting 1. So what am I receiving? This symbol plus the previous. Let us assume the previous value as 1, because initially we don't have any value, we will have an assume. So we have transmitted 1. So what are you receiving? You are receiving it as 2. How did you get 2? Because of the previous symbol. Now go for this particular case. We have transmitted -1. Okay, then what are you supposed to receive? You were supposed to receive -1. No, but that didn't happen. What was happened? You are receiving the current symbol along with the previous symbol. What was the mathematics involved? Along, what is the effect? What is the effect? That is current symbol plus previous symbol. So -1 plus 1 is 0. So that has been shown over here. Here you consider you have transmitted -1, correct? So you are not receiving -1. You are also receiving the previous transmitted symbol also. So therefore what has happened? -2. So on and so forth I am writing. So just observe the second row and the third row. What have you transmitted and what are you receiving? So this is the effect. So why did this effect appear? Because you have introduced the ISI. So what is the reason for this introduction of ISI? To have an increased symbol rate. So now we will stop over here and we will go back to the previous analysis. So now what has happened? We have received the signal BM. Whether the signal BM is the one which is intended? No. What has happened to the BM? So the BM, it is having the current symbol along with the effect of the previous symbol. Okay, so what was the effect? How it has been mathematically defined? It has been defined by the addition. So what was happened? Addition. What was added? The previous symbol was added. That is the effect. Okay, so now how would you overcome the effect of addition? The effect of addition would be overcome by subtraction. That is the meaning. If there is a problem, the problem has caused due to the addition. So how will you overcome the problem? You will overcome the problem by doing subtraction. So that is the basic case. So therefore, what they did was, so here why they have written this is the received signal till here. So now from the received signal we need to detect which symbol has been transmitted. Okay, so I have written the BM. Okay, so what was BM having? Current symbol and the effect of the previous symbol. So therefore how the effect was defined? Addition. So now what I will do? I will do subtraction. Therefore I will introduce this minus sign. So what I need to subtract? The previous transmitted symbol I need to subtract. That's what, because what was the effect of the previous transmitted symbol. So therefore what I will do? I will subtract with the previous transmitted symbol. I have introduced a cap symbol over here. The cap has been introduced. That I will tell. What is that is? That is nothing but you are estimating. What does this cap indicate in the equation number 25? Because at the receiver, you are estimating what has been transmitted. That is why we are supposed to write the cap over here. So now you tell me. So we have received the symbol 2. So what is this received symbol contains? The exact symbol plus the effect of the previous symbol. So therefore, what am I supposed to do? I have supposed to assume the initially the previous symbol transmitted was 1. So what you are supposed to do? 2 minus 1, that is 1. So now this would be the detected sequence. Now you check. You have transmitted 1, correct? What you received? You received 2, and you came to know why I received 2, because it was having the effect of the previous symbol. Now how will you decode? How will you detect? You are going to remove the effect. What effect you have observed, that effect you remove. So what was the effect? The previous symbol got added. Okay, this am, the previous symbol got added. So what will you do? You subtract with the previous symbol. 2 minus 1, that is 1. Just come over here. You have received 0. Then what will you do? You have to subtract with the previous transmitted symbol. What was the symbol which has been previously transmitted? 1. So 0 minus 1 is minus 1. Because remember, transmitter and receiver are not side by side as shown in the table. So transmitter is at one end, receiver is at another end. How come the receiver will know which symbol has been transmitted at the initial instant? It is having a memory. Initially, we will assume that the previously transmitted symbol was 1. Okay, initially we will store the memory with 1. Later, we will have the received symbol and we will do this subtraction. You know the reason for subtraction, 1. Okay, so now what has been understood? Okay, currently symbol 1 has been transmitted. So at the next instant you have transmitted minus 1. So you need to decode. Okay, yes. So what did you receive? 0. So you know the effect. So to get to obtain the or to detect the transmitted symbol, what you are going to do? 0 minus 1. Why minus 1? Because you need to remove the effect of the previous symbol. So that is the very simple case. 0 minus 1 is minus 1. So now consider this case. You have transmitted minus 1, you received it as 2. You came to know what is the effect. So therefore, how would you get the decoded sequence? Minus 2 minus of minus 1. That answer is minus 1. So this is how you are supposed to perform the decoding. Okay, so you have introduced the ISI, therefore you are getting the corrupted sequence, ISI corrupted sequence. You knew the effect, so therefore you are able to get back the original transmitted sequence. So there is a problem with respect to this particular thing that I will tell you. That is why the detected sequence has been given by AM cap is equal to BM. What you need to do? You need to subtract with the previous, you need to subtract the effect of the previous symbol. Therefore, I have written AM minus 1. Okay. Okay. The detected symbol at any instant is equal to the received symbol. Observe what is AM cap antandre detected symbol at the mth instant is equal to received symbol minus the previous symbol. That you are supposed to understand. Okay. Now, what was the problem? The problem is this. Over here, suppose during the decoding process, actually, let us consider this particular timing instant. I have shown both the columns. I have shown both the columns. Here, over here, the decoded sequence should be 1. But due to some problem, there will be a wrong decoding that as minus 1. So what have you transmitted? 1. So due to some problem in the circuitry or due to the effect of the noise, you will have minus 1. So now at the next instant, what have you transmitted? Minus. See, remember, this is the error cost. So this is an error in the decoding. So what is the effect of this error in the decoding? Further sequences will also be wrongly detected. Just observe, because at any instant, what are you doing? The received symbol minus the previous symbol. So if there is a error in the previous symbol, so 0, okay, then that the error would propagate, which is shown over here. 0 minus of minus 1 is 1, so you decoded it as 1. So what were you transmitted? What have you transmitted? Sorry, you have transmitted minus 1, you are receiving it as 1. So whenever you have an error, the forthcoming decoded sequence will also be an error. Okay, so because this is the case, so hence what you can observe this also. Again let me repeat this. Again let me repeat, there was a wrong there was an error happened in the decoding, so that at this particular instant you have got the decoded sequence as minus 1. Actually what it should be? It should be plus 1. Okay, that is the case. How can you check? So this is what the transmitted sequence. There was an error in the decoding, as a result you got it as minus 1. So now you proceed further, you have transmit minus 1. So what did you receive? 0. How would you decode the sequence? 0 minus of the previously detected sequence or previously transmitted sequence. So 0 minus of minus 1 is 1. Just observe what you have transmitted, minus 1, what you have received is 1. So now do the procedure. So starting from the point where error has been introduced, all further decoded sequences are erroneous in nature. So this is the problem. So the major problem with this particular controlled ISI is this particular method is, we any error happened, there would be any error happened in the decoding process, then if happens, then the error would be propagated. You can observe over here the error. Here there was an error, so rest all symbols were wrongly decoded. So this concept is called as error propagation. So tomorrow's class we will learn how to overcome this error. Remember, we cannot change the controlled ISI. We need to introduce the ISI. So we cannot go back, so that I don't want to introduce ISI, so therefore there won't be error. That should not be the case. We have to introduce ISI to obtain the high symbol rate, but we have to overcome this error propagation problem with suitable logic. That what logic we are going to do, that we will see in the tomorrow's class. Thank you.